Now let's just move on further towards the new topic, which is nothing but called as angle subtended by a chord at a point. So let us suppose if I'm just performing an activity and I'm taking a particular line segment joining any 2 points P and Q, and there exists any other particular point R which is not lying on the line PQ, and I'm just forming up an angle with respect to that particular line segment PQ at the point R. So let us suppose if the figure which is formed over here is nothing but of this form. So as you can see, this is the line segment that I have taken, and I'm calling these 2 points as P and Q, and I'm taking any other particular point R which is not on the line PQ, such that the line segment, or we can say that when I'm just joining P and Q with respect to the R, so there is an angle that is formed over here. So what do we call such type of an angle? We call such type of an angle as nothing but the angle which is subtended by the line segment PQ at R, because this is nothing but an angle which is formed by a line segment at the particular point R. So this is nothing but called as the angle which is subtended by a line segment. So let us suppose if I'm just performing the same activity but inside the circle. What does it mean? Let us suppose if I'm just talking about a chord PQ. So as you can see over here, there is a chord PQ over here, and this PQ chord of a circle is actually forming up or subtending an angle at the center of the circle, at the major arc, and at the minor arc of the circle. So you can see that there are 3 angles over here: at the center, which is nothing but called as POQ, at the major arc, which is nothing but called as PRQ, or at the minor arc, which is nothing but called as PSQ. So is there any relationship in between these angles? Because we can see that we have the equal chord over here, which is nothing but PQ, because all on these 3 angles, again these 3 angles are actually formed by the equal chord. So what can we say about such type of the angles that are formed by the equal chords? So this actually leads us to a very important theorem, which is all related with the equal chords and the angles, and which is nothing but called as a theorem number 1, which says that equal chords of a circle subtend equal angles at the center only. So it says equal chords of a circle subtend equal angles at the center. So now we have to prove that whenever we are just drawing up or we have the angles which are subtended by the equal chords at the center of the circle only, they are always equal to each other. So let if I am just forming up a figure for this one. So let us suppose if I'm just taking these 2 chords. As you can see, we have the 2 chords AB and CQ over here, such that they are forming up or subtending an angle at the center of the circle only. They are subtending an angle at the center. Now I have to prove that this angle and this angle, they are equal to each other. So let's just start with the given condition. So first of all, I can say that we have the 2 equal chords. We have the 2 equal chords A, B and CQ on a circle, and what do we have to prove over here? We have to prove that angle AOB is equal to the angle COQ. So we just need to prove that this angle and this angle, they are actually is equal to each other. We just need to prove this thing. Now let us suppose if I'm just starting with the proof of this one. So I can say that in triangle AOB and triangle COQ, first of all, OA is nothing but is equal to OC, being the radii of the circle. They are the radii of the circle, so definitely equal to each other. Again, OB is also is equal to OQ. Why so? Because they are again the radii of the circle. Again, we know that AB is nothing but is equal to CQ. It is already given to us that they are equal chords. So hence, we can say from these 3 things that the triangle AOB is actually congruent to the triangle COQ, which implies that the angle AOB is equal to the angle COQ. This is congruent to each other by SSS congruence criteria. By SSS, we can say that they are congruent to each other, and this thing happened by CPCT. By CPCT, we can say that they are actually equal to each other, and this is exactly what we have to prove over here, that the angles are equal to each other. So this is nothing but the proof of this particular theorem. So always remember, whenever we are just talking about the equal chords of the circle and they are subtending equal angles at the center only, at the center only, then those angles are always equal to each other.